Hi everyone, today we will be discussing constructivism in math and how it's played in a third grade math classroom almost daily. I chose this theory because I'm a teacher and I see this every day, how students learn best when they're actively engaged in discovering ideas for themselves rather than just being told what to do. And that is the center of constructivism. So I thought, what better way than to incorporate stations while doing constructivism. So please get your third grade thinking caps on. We're going to go over how constructivism can be seen in a third grade math classroom. I thought I'd keep it easy for you all and just stick with third grade, simple multiplication. This is one of the first things that teachers teach with multiplication, using pictures, arrays, number lines. So what better way than to combine it all and explore the different ways that multiplication is taught. Okay, so here's the task that you all will be doing today. So you will be rotating through 4 different stations to explore the different ways that multiplication can be represented. Each one shows multiplication in a different way. Your job is not to just get an answer, it's to look for patterns and make connections between what you see at each station. So at station 1, you will be using skip counting on a number line to show the multiplication. At station number 2, you will be using manipulatives and equal groups to build the multiplication problems. At station 3, you will be showing me using an array. And then at station 4, you will be using repeated addition. And then you will have about 2 to 3 minutes per station. So once the timer goes off and you've worked and collaborated with your peers at your station, you will switch. And of course it goes station 1 to 2, 2 to 3, 3 to 4, and then 4 to 1. So then we make the groups. The groups are formed. You start at that station, and this slide will stay on throughout the presentation in the classroom, just for guidance. Okay, so if you are at station 1, this is what you're going to see. You're going to see this number line that has 3 times 4, this number line with 5 times 6, and this number line times 9 times 3. So using these 3 number lines, you are going to work as a group. And so I'm going to act as if I'm in the group and what you would be doing during these 2 to 3 minutes per station. So what you're going to do is, because of constructivism being student-centered and not teacher-led or teacher-directed, you have to figure out how you put and represent 3 times 4 on a number line. So you have to think, okay, 3 times 4 is telling me there's 3 groups of 4. Well, okay, I know the whole problem, 3 times 4 is 12. But if I didn't know that, how can I use this number line to help me solve? And so the objective of this is to use a whiteboard and a marker. And I'll have that provided in person. But this is essentially what you would draw on your whiteboard. This is what you would see if you're at station 1. The first paper, there's 3 papers in total because there's 3 multiplication problems at each station. They are all the same. There's 3 times 4, there's 9 times 3, and there's 5 times 6. So the first one, you work with your group to collaborate and discuss, which is a part of constructivism, to try and figure out how you represent 3 times 4 on a number line. And I'm going to simply show you. So you talk and talk and talk with your collaborating group, figure it out. You say, okay, I know that this problem represents 3 groups of 4. How can I show this on a number line? Maybe you already know the answer is 12, so you can figure out how can I go from 3 times 4 and get 12, and this is what it should look like. But on here, 1 group of 4, right? Because I skip counted by 4. I jumped 4, so that's 1 group. 2 groups of 4, I would have 8. And then 3 groups of 4, I would have 12. So I'm counting by 4 every time. And if I do 3 groups of 4, that's how I end at 12. So that is what the number line should look like. Another one, if we have 5 times 6, same objective. On the number line, 5 groups of 6. So the first time I will be counting by 6. So I jump 6 spots. I need to do this now 4 more times. I already did it once, but I need 5 groups of 6. So here's my second group of 6, and I get to 12. I'm counting by 6 every time. And here, keep in mind, you'll be collaborating and discussing with people, asking questions throughout, like, oh, how did you do that? How come you counted the 0? How come you didn't count the 0? So on and so forth. Third group of 6 gets me 18. Fourth group gets me 24. And then finally, I land at 30, which is my answer. And once again, I can't stress this enough, collaborating, working together. Learning is a social activity. That's a big part of constructivism. And then for the last one, it already kind of jumped to it, but 9 times 3, just to kind of make this go faster, we see that we're counting by 3 every time because we have 9 different groups of 3, and that's what gets us our answer of 27. And then for the remaining minute or so in each group, if there's time, I have a set of discussion questions to talk about. So all these questions are great for discussions in order to get the groups talking and communicating about using a number line. So then if you're at station 2, you're going to be counting cubes. You could build it almost like an array, so it is kind of like station 3, so you can get the total. But for me, if I'm doing 9 by 3, that means I'm doing 9 groups of 3. So here's my first group of 3. I need 8 more groups. Here's my second group of 3, third group of 3, fourth group of 3, fifth group, sixth group, seventh group, eighth group, and ninth group. So altogether, this is 9 groups of 3. And then with 3 by 4, it's essentially the same thing. I'm using those manipulatives to build, okay, here's my one group of 4. Here's my second group of 4. And here's my third group of 4. And then you can count either 4, 8, 12, or they just count one on one until they get to 12 and get the answer. So station 2 is a little bit quicker, but that's okay. And then 5 by 6. So I have 5 groups of 6. There's 1 group, there's 2 groups, 3 groups, 4 groups, 5 groups of 6. Okay, so 5 groups of 6. So there's 5 groups shown with 6 in each. And count by 6s and do 6, 12, 18, 24, 30. And then, of course, again at station 2, there are some discussion questions for if they have extra time and they're done building their multiplication models with the cubes. And then station 3, we're representing 5 times 6 with an array. So an array is just like rows and columns. This is one of the most popular ways to represent multiplication early on. So if I'm doing 5 times 6, then a 5 columns with 6 rows. 5 times 6 is going to get you 30. And then they can either count by 5s going across, by 6s going down, or they get one-on-one counting and just get to 30. And then with arrays too, you're going to be given a rectangle, so just drawing it inside the rectangle is another good way to represent the arrays. And then 3 by 4, so I'm going to have 3 rows. In this case, I did 4 rows of 3. By 4, they can count by 4s going across, they can count by 3s going down, but either way, you're going to get 12. And this is how you represent it using an array. 9 times 3, so 9 columns of 3, so 3 rows of 9, which is opposite of what it says, but it gets you the same answer. So they can either count by 3s going across or 9s going down, or count one-on-one and would get your total of 27. And then of course station 3 also has the discussion questions to think about if there's more time. And then station 4 is just repeated addition. This one is pretty straightforward. I have 9 groups of 3. That is me counting by 3 9 times. So 3 plus 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 3. Could do 3 plus 3 is 6, and then combine all the double 3s to get 6, and then add 6 plus 6 plus 6 plus 3, which would get you 27. Or you could do 9 plus 9 plus 9, right? So there's so many different ways. And then same thing with this one, 3 times 4, so 3 groups of 4, 4, 8, 12. Or 4 plus 4 is 8, so then 8 plus 4 is 12. That's just simple repeated addition. And then the last one is 5 times 6. So there's 5 groups of 6. So once again, you can combine 6 plus 6 and get 12. And then 6 plus 6, 12. You get 24 plus 6. Or you could do all 6s at the same time. So many different ways to do repeated addition. And then, of course, at station 4, more questions and discussion topics to think about with the groups so they can collaborate and really figure out, especially because this is the last station, what station worked the best for them, and then hopefully it made sense to them, and then they stick with it throughout their multiplication journey. So now that all the stations are done, once all the time has gone through and everyone's got to all the stations, we're going to take a few minutes to reflect. So I have 3 reflection questions that we will discuss as a class. Once again, we just saw constructivism in action. So you started with prior knowledge of basic multiplication facts. You explored the possibilities with a number line, array, repeated addition, and you tested your own reasoning and then refined your understanding through the collaboration and discussions with your group. And that's how learners construct the meaning of what is being taught, individually first and then socially. So when we design classroom lessons or e-learning using constructivism, we want to create moments like this where the learners get to explore, reflect, and talk through their reasoning instead of just being told the answer. Thank you.